Welcome back. In the last video, we saw how to tune a model's hyperparameters using randomized search CV. And what that did was we defined a space or a dictionary of different hyperparameter values we'd like to try, and then randomized search CV combined these parameters at random and built a classifier with different settings, different hyperparameters, and then evaluated them all using cross-validation. Or we might change this back to 10. We don't want 50 models running off. And then after trying 10 different combinations, it found the best parameters to be this set of values here. Then after evaluating them, we saw it didn't really do as well as our previous model up here where we tuned just by hand. And so finally, a workflow you might end up with when you're tuning hyperparameters is starting off by hand and then using randomized search CV across a space of hyperparameters. And then once you've found some pretty good hyperparameters, you'll probably finish up with grid search CV. Let's see that in action here. So 5.3, hyperparameter tuning with grid search CV. Beautiful. And let's check out our grid. So our grid at the moment is, you might notice the grid search CV has the word grid in it. And our grid of hyperparameters at the moment are these values here. And the key difference here between randomized search and grid search CV is that randomized search CV has a parameter called niter, which is what we saw up here, which we can set to limit the number of models to try. So in our case, we used 10. So if we look back up here at the top of this code, fitting 5 folds for each of 10 candidates, totaling 50 fits. The key difference between randomized search CV and grid search CV is that grid search CV is kind of like a brute force search. It means it will go through every single combination that is available here. So if we have a look, we've got 6 values there. So it'll be 6 times 5 times 2 times 3 times 3. So there's 6 parameters here, there's 5 here, 2 here, 3, 3. In total, 540 different parameters that it would try, or combinations of parameters. And that's a lot. And then cross-validated, so times that by 5. So 2,700 models. That's a lot, right? That's going to take a lot of compute power. Training one model might take long enough time, but training 2,700 of them, especially if you're working with a large data set, probably not going to be suitable for your laptop. You may need a big computer, or we can reduce the search space. So let's see that in action. So what I mean by that is we'll create grid 2 using a little bit more of a confined hyperparameter space. So in essence, just reducing the number of hyperparameters grid search CV has to go through. So let's see this in action. What we might do is just copy this. And now how would you create grid 2 in practice? We could just copy and paste it, which we've done. I want to line these up so it all looks Pythonic. There we go. Now we could just copy and paste it and then just delete these at random. Delete, delete. But we might not do that. Say we've gone through randomized search CV and it's gone through, let's say we up this to 50 different models like we had before, but in our case, we've only actually done 10. We might take these parameters, the best params from our randomized search CV, and use them to influence where we'd like grid search CV to run. So let's do that. Our best parameters is 200, 6, 2, square root. So what we might do, remove 10, keep 500 there, remove these two. Yep. Max depth is none. So we might just keep that as none. So it's only got one option there. And then for square root, we might actually keep that as auto or square root. And then what else do we have? Min sample split is 6. We might get rid of 4 and 2. And then what we might do, min samples leaf. So we might keep that as 1 and 2. So what have we done here? Well, what we've done is we've reduced our search space of hyperparameters. So now, if you remember, we had 540 different combinations there. What do we have? So we have 3 times 1 times 2 times 1 times 2. So 12, and then it's going to be cross-validated 5 times, so we can adjust this using the CV parameter. So 60 versus 2,700. So that's a lot less parameters there. So how would we do this in practice? How would we use grid search CV to find the best hyperparameters in this space? Well, as always, let's see it in action. From sklearn.model_selection, import grid search CV, and we want to import as well train test split. We probably already have that. We can put that there. Random seed, wonderful. Split edit. What we might do actually is just bring this code up here because it's the exact same code that we want to use before. So we'll just take this, except we're going to change one thing. Come down. Wonderful. So we're using the same data set as our randomized search CV, making the same split. We're instantiating a random forest classifier, but this time we're going to set up grid search CV. Grid search CV. Wonderful. Grid search CV. And then we're going to fit it, the grid search CV here. And now there's a different parameter here. So this one is going to be param grid, I believe. It's not going to have an iter because grid search CV is like brute force. It tries every single combination. And we want it to try our grid 2, not grid 1, because it's got a few less options there in grid 2, as we saw before. So we'll come down here, keep cross-validation as 5-fold. Verbose equals that. Okay, now let's step through what's happening. So we're importing grid search CV. We've created grid 2, which is a refined search space of different hyperparameters, so different settings. So much like if you were working on your favorite meal, adjusting your oven, if you set the temperature to 400 degrees, that's way too high. So if it starts off at 180 degrees and it does okay, you might go, why would I go right to 500 or 400 degrees when I can just make a little jump to 400? So that's why we've created grid 2. We've based it off the best parameters or the best hyperparameters that our randomized searched CV or the randomized search CV has found. So let's do it. Let's build a random forest classifier using grid search CV. So here's how it's going to go again. Same thing again, fitting 5 folds for each of 12 candidates, totaling 60 fits. Now what grid search CV is going to do, just like randomized search CV, it's going to go through all of these different hyperparameters and pass them to our random forest classifier, trying each different combination, and then eventually, when it's finished, we'll be able to go GS-CLF best params. Wonderful. So it might take a little while with grid search CV. This is something to keep in mind. The more hyperparameters you have in here, the longer it will take grid search CV to run because it has to try every single combination of hyperparameters in here. So now, as we did before, we can evaluate our grid search classifier by making predictions with it and then using our evaluation function to figure out how it did. So let's do that. GS-CLF, or actually, we'll go GS-YPreds equals GS-CLF.predict. We'll predict on the test data as well, X-test, and then we'll go evaluate the predictions. GS metrics equals evaluate preds, our function that we defined a couple of videos ago, and then we'll go GS-Y-preds. Wonderful. And now, again, we see a slight decline in accuracy. And that just goes to show how much of a process tuning hyperparameters can be, right? It's all about that trial and error. What you could do to fix this is go back up. Your workflow would probably be try a few settings by hand, as we did right back up here. Tuning hyperparameters by hand. This is the workflow you'd probably do. Try adjust a few of these by hand, see if you can figure something out with a validation set like we've done. And then try some hyperparameter tuning using randomized search CV. You might, in this case, up this number to 20 or 50 or so, or whatever arbitrary number that you find. Again, this is all experimentational to try and figure out what hyperparameters are better. And you might even change the grid that you're searching over based on the hyperparameters you find in the Scikit-learn model documentation for the model that you're using. And then once you've found some good hyperparameters using randomized search CV, you might take those hyperparameters, these ones here, best params, and then create another grid to grid search over, like we've done here. In our case, it hasn't improved our model's metrics, but this is where we'd probably start to experiment a little bit more, try a few different other metrics, try a few different other hyperparameters. But for completeness, what you'd probably do then, after you've tried a fair few different hyperparameters, you've created a baseline model with the default settings, you've tried to adjust them by hand, you've tried to adjust them by randomized search CV, and you've tried to adjust them by grid search, you're going to want to compare your models. So let's compare our different models metrics. Wonderful. And to do so, we're going to create a data frame. So PD, this is why we've been returning dictionaries from all of our models and our evaluate preds function. So baseline is going to be baseline metrics, and then CLF2 is going to be CLF2 metrics. Type in M's here when we don't need them. Random search is going to be RS metrics, and then grid search is going to be GS metrics. Wonderful. And then to see it in action, we're going to go compare metrics, which is just our data frame that we've instantiated here. Oh, we might need to move this up there. There's going to be an error there, isn't there? That's an extra squiggly bracket that we didn't need. Dot plot, dot bar, fig size equals 10, 8. Let's see it. Wonderful. So this is going to compare all of our different classification models metrics in the one space. So we can see our baseline model is the blue. So on this one, it didn't get the best here. It was more of a tie between CLF2 and random search. On precision, CLF2 is out in front. On recall, baseline is out in front. And on F1, it's a tie between baseline and CLF2. And again, you could adjust this graph to make it more visible. This is just to demonstrate different metrics. And so this is the kind of communication you do for not only yourself, but for your teammates, or if you're reporting to someone in a project, is to show them the different models that you've tried and then how they perform differently on different classification metrics. If you're working on a classification problem, of course, you can do the same sort of process with a regression problem. And now, depending on what you need for the project will depend on which model. So say you wanted a model that optimized recall. In this case, you might use the baseline model. Or if you wanted a model that optimized precision, you might choose the CLF2 model. And if none of these metrics really worked for you, you might continue to try to find some better ones through random search or grid search. And now, we finally got to the end of how you can improve a model via hyperparameter tuning. And again, there's a lot to take in here. The key point is to remember it's an experimental process. Improving a model through hyperparameter tuning there's no sort of written law on how you do it. But the point is to just keep trying, see if you can figure out something, see if you can get yourself familiarized with different hyperparameters that different models have, such as the random forest classifier, and just remind yourself that the first model that you make is more than likely not the best model that you will have. It's a baseline model and it can be improved upon. And so, built a model, we've tried to improve it. Let's say you've decided you're going to focus on recall or something like that. You may want to export your model so you can share it or use it in some sort of deployment setup. So in the next section, we're going to look at, if we look at our list here, what we're covering, we're going to look at how to save and share and load a model. So save and load a trained model. The benefit of this is that you won't have to retrain a model like we've done in the past few sections. So go back through, check out what we've covered with hyperparameter tuning, how to improve a model, hyperparameter with grid search CV. Try it out with randomized search. Try it out by hand. And I'll see you in the next video.